also connect this world of exponential function back to the ideas of shifting, stretching, and reflecting transformations, and that's what example 3 is asking us to do. So as you look at example 3, the first thing to note then, in the world of transformations, we would always start off with our base function. So when you look at the graph of y equals 2 to the negative x plus 3, you want to start by saying, oh, this has to have something to do with the base function y equals 2 to the x. Well, we just talked about the graph of y equals 2 to the x. So some of the interesting things we remember about y equals 2 to the x's graph, we have a horizontal asymptote of y equals 0. It goes through the point negative 1, 1/2. It goes through the point 0, 1. And it goes through the point 1/2. And it's a nice increasing function from left to right. Well, now that we have that reminder about what the base function looks like, let's think about then what all the other pieces and parts are going to do for us. So y equals 2 to the negative x. If I multiply that x by a negative 1, that means then that we're going to end up having a reflection. And in particular, this is going to be a horizontal reflection. And because it's a horizontal reflection, that means that it's going to be reflected about the y-axis. So if I reflect this graph about the y-axis, I like to start by thinking about what that does in terms of my asymptote. So take y equals 0 and reflect it about the y-axis, and it's still going to be y equals 0. So, okay, my horizontal asymptote is still y equals 0 here. And any point on the y-axis isn't going to move, so 0, 1 is still going to be a point. 1, 2, however, if I reflect it about the y-axis, 1, 2 is going to come over, and it's now going to be negative 1, 2. Remember again that if we're reflecting about the y-axis, I'm going to multiply my x coordinates by negative 1. So negative 1, 2 there. And then the same kind of thing happens with negative 1, 1/2. Multiply the x coordinate by negative 1, and we're going to have then over here a point 1, 1/2. And now we have this graph. Now something interesting to note is that by reflecting this exponential graph about the y-axis, we now have a graph that, instead of increasing from left to right, decreases from left to right. Well, let's keep on seeing what else we can do now. So the last piece then is to notice we have this plus 3. Adding 3 on the outside like that means that we're going to have a vertical shift. And in particular, it's a vertical shift up 3 units. So, okay, once again, I like to start off with my asymptote. So y equals 0, if I shift that up 3 units, is going to actually be now y equals 3. And all of my other points are going to get shifted up 3 units as well. So negative 1, 2, add 3 to that, we're going to be at negative 1, 5. 0, 1, add 3 to the y-coordinate, we're going to be at 0, 4. And then finally over on the right, 1, 1/2, we're going to add 3 to that, and it's going to be 1, 3 1/2. And we have our decreasing function. So now that we have this graph of y equals 2 to the negative x plus 3, we can go ahead and check out old friends, domain, range, and we can also write down that horizontal asymptote. So the domain, once again, is the set of all x values used to create this graph. I go forever to the left and forever to the right, so the domain is still going to be all real numbers. Range. This one, once again, remember that the range is the set of all y-coordinates that create this graph. Well, I don't use every y imaginable. I go down, and the lowest I ever get to is close to this y value of 3. So that means that my y values are 3 and above. But I don't include that 3 because I actually don't cross that horizontal asymptote. So I'm going to have a parenthesis next to that 3 to demonstrate the fact that I'm not going to cross through that horizontal asymptote. So parenthesis 3 comma infinity would be my range. And then finally, once again, the horizontal asymptote, you always need to write it as an equation. So the equation of the horizontal asymptote is y equals 3.